All right, this is like a, you can close your Chromebooks there. You don't need them. Okay, this is like an amendment here to 7.6 because you can see that it's 7.6b. So it's just kind of a little extra playing off of volume here, but we got to cover a few concepts. Okay, and one of them is volume, which we will spend probably no time on because we did that all day yesterday. That was on. But the other one here is surface area. Okay. So I guess the first question that I have to you is volume we know from yesterday is 3D, yes. Right? And we had, right, our little cube or rectangular prism, and now we know what a prism is. Okay, surface area has to deal with what dimension? Okay, on. Okay, this is two-dimensional. Okay, so this is just a square, and the word that we associate with it is flat, right? Okay, so here's the catch, if you want to say that there is one. So today we're going to use a three-dimensional figure to find the surface area of the object. Does that make sense? It's like wrapping a present, right? All the sides are covered, yes? Okay, with wrapping paper. So we're going to find the surface area that it takes to cover a three-dimensional figure. Everybody good with that? I'll assume your silence means yes. Okay, so the definition of surface area would be the sum would be the sum, which means to do what in math? Add. We are adding. Okay, the sum of the areas of its faces. What does that mean? What are faces, Grayson? Okay, the sides, all the flat pieces that we call two-dimensional, when you put them on a 3D figure, they are called faces. They are also called polygons. Okay, but since they're all connected, we're going to call them faces. How is surface area measured? You should know. Surface area is measured in, come on, we've already talked about this shape right here. Ready? Square what? Square units. Okay, yesterday, remember, we dealt with centimeters cubed, faces and polygons and two-dimensional figures are measured in square units. We've already went over that. Okay, and the last term we're going to throw out today is something called a net. No, it's not a net to catch fish. Anybody know what a net is? Nobody? No, it's not a basketball hoop net, sorry. All right, let's define this then. You can find the surface area of a three-dimensional figure by using two-dimensional representation of a figure. Now, that's a big definition. I don't know if that's confusing or not. Bless you. But the word here that I would like to associate with net is unfold. Okay, and I have some examples here for you to see, and you'll see what this means. It's really not as difficult as that definition kind of sounds. All right, everybody good with that? You got that written down? All right, so here's our three-dimensional shape. Okay. We're focusing on surface area. You already know how to find the volume, right? You did that last night for homework. Nobody had any questions, so I'm assuming you did well. Right? That would be simply 6 times 5 times 9, and you got your answer for volume. Right? Make sure that you put the appropriate label, meters cubed. Okay, so what we want to do is we are going to cover, right? Now I'm going to try to color code this the best I can. It's going to overlap, but the two that I just outlined, wouldn't you say that that would be the front and the back of the object? Is that fair to say? Okay, so we want to find the dimensions to find the area of that face. In other words, we want to find the length and the width. Okay, what is the length and the width? Anybody know? Now, this is more of a visual. I mean, once you figure this out, the math is easy. We've already done the math throughout the entire school year. Okay, but this is more of a visual to make sure that you get the right number. Okay, so 9 is the distance, right, from here to here, right? And we want to find the height, so that we would use 5, correct? So the face, let me shade this in here so you can see this. The front face right here, yes, is 45 meters squared. You agree? Okay, would you agree that the back is the same? So guess what we're going to do? We're going to multiply by 2 to get 90 meters squared. That is the front and the back of the object. Does that make sense? Okay, because it's easy to get confused here. Okay, so let's try the sides. See if I can. All right, we're talking the sides of the object. Okay, what is the length and the width of the sides that we would multiply together here? Maddie? That is correct. 6 times. Look here, though. The 5 is on this side, the right side. The 6 is over here telling you that's the length there. But going up, this measurement is on the other side. This is where you just got to be careful. You have to recognize where things are at. Bless you. Okay, so that equals our 30 meters. squared, sorry. Okay, you agree that those sides are the same, right? So we're going to multiply that by 2, and that's going to give us 60 meters squared. So far, so good. And then we need a measurement for what? What do we got left that we got to figure out? The top and the bottom. Okay. The top and the bottom would be overlapped here because the bottom, well, that's blending in colors now. So we got the top and the bottom. That looks crazy. Okay, what's our measurements for the top and the bottom? Length and width. What do you think, Jen? 6 times 9. 6 times 9 gives us what? 54 meters squared times 2, because the top is the same thing as the bottom. That's going to give us 108 meters squared. Okay, so we've found the measurements for all of the faces. The definition said, what did it say? The what of all of the faces? The sum of all of the faces. Right? So we're going to have to add that up. And when we add that up, we're going to get 258 meters squared. That's what it's going to take to cover that rectangular prism. Now, here's the nice thing. We're gonna encounter some other objects here in a minute. But here, what do you notice about our mathematics with a rectangular prism? It's a lot. Well, you haven't seen anything yet. You think that's a lot? How many calculations did you actually do? You did 3, right? But there's 6 sides. Why did you really only have to do 3, but there's 6 sides, Emma? Okay, opposite sides are the same thing. When you get a rectangular prism, I mean, you should be really happy because you're really only doing three calculations and you're doubling them. Okay, that's the beauty of a rectangular prism when it comes to surface area. Okay, because the opposite side is the same. Okay, it doesn't always work out like that though. We have different shapes and different sizes. Everybody good with that, right? That's not difficult. It's you gotta be careful. Make sure that you're getting the right numbers that you need to get. All right. Try that one. We're finding the surface area. We want to wrap it like a present. Now, I say that, I know presents, the wrapping paper is overlapped and all that stuff. We're not overlapping anything. Okay, we're just covering the faces. You can use the Desmos calculator if you need to. But you got to write down your math. You got to write down what you're multiplying together to get the surface area of the faces. Please do not just say, "Oh, I did it on my calculator." No, just write it down. What 2 numbers are you multiplying together? This isn't difficult. Bless you. Anybody got something? Anybody need more time? No? Okay, what do you got? Give me some answers. Michael, what'd you get? 340? Okay. No, I just want to make sure I heard you right. 340 feet squared. Brady, what'd you get? How many? Okay. Anybody else? Nobody else? Come on. What'd you get? 248. Okay, very good. Anybody else? Cohen, what'd you get? You get one of those? All right, so let's check this out. So let's do this one. Right, that's the same thing as the back. What measurements are we using for that? We'll just say that's the front. I get front and back, I guess. What are the measurements for that? Just yell it out, Brady. All right, 8 times 3.5 is going to give us 28 times 2 is going to give us 56. Okay, very good. What about the side here? What is this measurement? 10 times what? 10 times 3.5 will give us 35 times 2 is going to give us 70. And now we got to do the top and the bottom, right? And that is going to be 10 times 8, which is going to give us 80, which is going to give us 160. And when you add them all together, you get 286 feet squared. How many of you got that? Ooh, yes. Okay, very good. All right, moving on. Okay, so this is what it looks like. And the reason I put this up here is I want you to see what a net looks like. Okay, remember that three-dimensional figure right here that we said? And it said what? Using it to be a representation of a two-dimensional figure. So if you would unfold that object, that is what it would look like. Now, here's what I will tell you. This is a little bit of, it's called geometry and spatial sense. Some of you are cognitively here faster than others. It doesn't mean that you don't know how to do it. It doesn't mean that you can't do it. Some people can see it better than others. It's just your development. That's all it is. But the more you do it, it's like anything else, the better that you would get at it, basically. Okay, but they're unfolding a two-dimensional figure. Sorry, unfolding a three-dimensional figure. This is what it would look like if you would tear it apart. Okay, now we're not going to spend time doing this. Normally we probably might, but we're not. But look at here's what I want to point out though. Look at the measurements. Are all the measurements still the same? Look here. Sure they are. You got the top, you got the bottom, you got the front, you got the back, you got the side, you got the side. Again, it's a rectangular prism, so if you look at the math, bless you, they just doubled each one of them, right? But the point of this slide is this. This is what a net looks like. They may give you a net. They may give you the three-dimensional figure. I don't know. Okay, but from there, they will have markings. And from the markings, you already know how to find the surface area, right? Or the area of a two-dimensional figure. Everybody good with that slide? Yes? You good with the nets, right? It's just figure that's unfolded and lays flat. Now it's a two-dimensional representation of the 3D figure. Okay. Ooh, and then it's going to get good. And now we have, this is a net of a triangular prism. Might want to pay attention. Okay, three-dimensional figure that has two-dimensional triangular faces and three rectangular faces. Okay, how, or I should say why, is it called a triangular prism? What was our definition yesterday of a prism? Ready? No. What makes it a prism? Yes, it's a 3D shape, but what makes this a triangular prism? This isn't a rectangular prism. There was something that I said that was really, really important to pay attention to, and I emphasized it a half a dozen times. Cullen? Okay, what about them? Did you say face or base? Okay. What? That's not it. Oliver? No, this only has 5. Brady? What makes it a prism? Please look in your notes. You should have wrote it down. I asked you to. I believe we wrote it on the board. It's a 3D figure. That is correct. But what makes it a prism is that it has. See, I don't think any of you wrote it down. The sides that are parallel to one another. I want to write that down since we don't have it. The two sides that are parallel to one another are triangles. Hence, it's a triangular prism. Yesterday, they were rectangles. That's why they were called rectangular prisms. The two sides that share the same shape and are parallel to one another, that's how it becomes a prism. Okay, this one is kind of difficult because if you see, they start with the 3D figure, and you can see in the middle there, they're unfolding it, which there's my word. Okay, and then there's our 2D representation. That's hard to draw, children. Now, I'm not going to lie to you. That's tough to visualize that. If you don't have the figure in your hand and are unable to unfold it, that's hard to draw. Okay, the good news is I don't believe you have to draw any of them. You gotta understand it. You gotta make sure that you know going from a 3D to a 2D is called a net. Not only that, on the previous slide here, you got to make sure that you look at the markings because they may have a net for you, and you're going to have to find out the surface area of the net given a surface area of a net given the net picture. Oops, wrong one. All right. We got the prism down now. You sure? Parallel is the key word there. All right. This is tough. Before we try one. Okay, so here I like to call this is our slice of cheese. Okay, so there may be a couple things that you may be able to calculate twice, and in this case, it's only the front and the back. Okay, because if you recognize this right here and the back of it are the only ones that are the same shape. Bless you. It's the only one that's the same shape, same size. Everything else is a single calculation. Okay. The hardest part of this is making sure that you get the right numbers to multiply together. That's the hardest part. You've got to look carefully at the figure and make sure that you get the length and the width of the correct side of the shape that you're trying to calculate. Does that make sense? For example, let's make this point now. Look over here. I'm over here on the net. I'm drawing the arrows. I'm over here. Okay. We want to find the measurements of that triangle right there. My question to you is, are we going to use 13? What is 13 called? Who remembers? See, this is where they kind of trick you. And I say it's tricking. They're not really tricking you, but you have to know what the markings are and of a triangle and where they are and what they mean. That's called studying. That's called knowing it. Pucky, what's the 13 called? That's the hypotenuse. That is the opposite side of a right triangle. That's why they give you that measurement there. We do not use those measurements right now. We haven't dealt with hypotenuse, so don't use it. But guess what? It's on there. And you've got to know those things. You've got to use, in this case, you've got to use 12 and 5 to figure out the surface area of the triangle. Does that make sense? You've got to know the markings. In my opinion, that's the hardest part. Figuring out which numbers to use to find the polygon that you want or the face that you're trying to find. Because let's face it, the math is easy. You're multiplying two numbers together and you're adding all of the rest. That's not difficult. Getting the right numbers, maybe. Okay, everybody okay with that? All right, let's try one. Similar, but not the same. Okay, we'll do this together. Okay, so let's first, what do you want to find first? Okay, what do you want to find first? All right. So let's find the triangles first. I'm good with that. So that's the front and the back. Those are the same. Okay, so the triangle is what? What are we going to multiply together? Go ahead. All right, 3 times 4. So our area of the triangle is 12, yes? Ooh, Emma, why no? Yes. See, very good, man. Triangle, you got to divide by 2. You'll forget that part. Nice job, Emma. You'll forget that part. Now, you have 2 of them, so yes, we go back to 12. I get that. Okay, but sometimes there may only be 1. Okay, so our 2 triangles add up to 12. What do you want to find next? Ready? Okay, so that's fine. We'll find the back. We'll find that right there. Okay, and it looks like a square. What's our measurements for the back? Okay, going. Okay, 3 and 4. Look here. The measurement here, I'm trying to thicken this in here for you. The 4 is right here. That's the measurement back here. That's 4. So you're right. Again, we got another 12. Very good. What do you want to find next? Michael, what do you want to find? The what? The front, the slanted front? Okay. So we want to find the slant here. What are the measurements for that? We'll say that's the slant. I think that's what. Okay, what are we going to use there? Go ahead, just yell it out. 5 and 4. It's going to give us 20. Here's the 5. Here's the 4. Length times width. Bless you. What do we got left? We got one more. Emma? Okay, we got the base or the bottom. That is correct. That would be this. We got to figure that out. What are we going to use for that? 4 times 4. It's going to give us 16. Okay, have we found everything? I think we have. Okay, I would highly recommend this. If you're not seeing, I'm doing them like I guess I would expect you to do them, right? I'm labeling them what I'm finding: slant, back, base, triangles. Because in case you make a mistake, you're not going to know where if you just have a bunch of numbers thrown on a piece of paper. Okay, especially when you get to, we got 4 different sides here. And if we add those all up, I believe we get 60 yards squared because we are finding the area, the surface area of that object. Does that make sense? Okay, I'm giving you a heads up. The key here is make sure that you are multiplying the right numbers for the right face or polygon that you're trying to find. That's the hardest part. Everybody good? And now we have something called a square pyramid. Okay, why do you think it's called a square pyramid? Jason? Okay, the base tells you what it is. This is a square pyramid. Are all pyramids square? No, they are not. Okay, but Chase is correct. You got to look at the base. It tells you what it is. Okay, so again, here we go. They're unfolding it. And then finally over here, we get the net of what a square pyramid looks like. Now, what's the nice thing here? How many calculations do you have for a square pyramid? You only got 2. You got the base, which is different. And then if you figure out one side, what are you going to do to that answer? Multiply it by 4. Okay, now in this case, once you get that answer, what do most people forget to do? No, well, okay, you are correct. Forget to divide by 2, but once you found your answer for the triangles, most people forget to add the base back in. Because remember, we're finding surface area. Yes, you wrap the bottom of presents. You got to wrap the bottom of your square pyramid here. Okay, so this is kind of what it looks like. Okay, again, here's the bottom. There's the 4 sides that are the same, right? We said that that was one calculation. Okay, but don't forget to add back in the base or the bottom. Right? Okay, try one. You can do that. No, don't raise your hand. Go ahead, crunch your numbers. Find the surface area of our square pyramid. All right, what do we get for the bottom? What's our calculation? Jen? 5 times 5, right? Okay, because if it's a square, if this is 5, that means that's 5 over there, that's 5 over there. Okay, what's our calculation for our triangle here? Grayson? Yeah, there you go. Okay, so 25, we get 12 and a half is one triangle. Okay, make it easy for yourself. You're going to multiply that by 4 because all of these are the same. All those other ones. Okay, and when we do that, we get 50. 50 and 25, you should have gotten 75 centimeters squared. Maddie, I have no idea why you're on your computer. Everybody good with the square pyramid? Everybody good? I do not. Okay. Thought I had another one. All right. We feeling comfortable? All right. Now listen carefully. So in a minute, I'm going to come around and pass out a handout on surface area. Plus there is a record and practice in the folder today. You need to do all of that.